So now we are going to play with a completely and totally different method. I'm trying to do this so you can see, of graphing. So everything that we've done until now, ignore that. We have done an x-axis and a y-axis, and this is the origin, and then we have quadrants 1, 2, and 3, and 4, and blah, blah, blah. There's also a z-axis that comes out towards you and then goes back in towards the desk, whatever. But sometimes it's not as friendly to graph in an xy coordinate system. So we call that a Cartesian coordinate system because Descartes, which is not Descartes, but Descartes, is the one that came up with it, okay? So what we're going to do at this point is introduce polar coordinates. So in rectangular, which if you'll think about it, this is a rectangular system because the little grid marks make rectangles or squares. So a rectangular notation or Cartesian notation, these notes are out on canvas and it will say polar coordinates and pretty pictures. Normally you would have an x coordinate and a y coordinate, and so we're going to kind of sort of mess that up a little bit. And then I want to have some method of conversion. So if I have an x value or a y value, how do I translate that into polar? And again, if I've got a ratio, how do I translate that into polar? And so what we end up with is instead of an xy, we have a radius and a theta. So it's going to be r theta. If I'm given an x, I can convert it by using r cosine theta. So your radius times the cosine of theta. If I've got y, its polar notation is going to be r sine theta. I can have a ratio of y over x, and that's going to be equivalent to tangent theta. And then this is where we're going to have fun, because you should recognize that this is Pythagorean Theorem. So we've got x squared plus y squared equals r squared. Well, in rectangular coordinates, it's x squared plus y squared. But in polar coordinates, it's going to be r squared. So when we start converting these things, we're just going to kind of sort of hop back and forth between the two. But what we want to do first is, hang on, I've lost my paper, is we want to convert a few of these things. Okay, so this is, I made pictures for you. This is basically what polar coordinates looks like. So you have this is not called the origin, it's called the pole. So P-O-L-E, like the North Pole, but it's a pole. Okay, and then what we'll do first is we're going to find out what the radius is, and then theta is going to tell us how to swing around. So the easiest way to look at this will be if I have a positive radius and a positive theta, all you do is from the pole, count out to the right that many units for a radius, and then swing up and around that many units for the angle measure. So what does that mean? What is she saying in real life? What this means is if I've got 2, that's your radius, and then your theta is 135 degrees. So what we're going to do is, and I'm going to do it on here, from the pole, I'm going to scooch out 2 units, okay? So here's 1 unit, here's 2 units, okay? And then I'm going to swing around 135 degrees. Now, we're not expecting like vast amounts of precision here, so basically I just need you to recognize which quadrant you land in. So if I count out 1, 2 as a radius, and then swing around, so notice I'm following that little guide right there, and swing around to about 135 degrees, which is going to be somewhere right in there, okay? So you're essentially in quadrant 2, correct? So if we come over here, well, you'll notice your options are either in quadrant 1, quadrant 3, quadrant 4, or quadrant 2. So we're not trying to get you to be exact about this. We're trying to familiarize you with it. And so in this case, your answer is obviously D, okay? Well, now, my other option is, holy cow, now I've got a negative radius. So I have a different way of handling it than this particular publisher does. So if you do the help me solve this or the practice another version, they're going to talk you through it a different way. But I'm going to show you my way because I like it better. So basically, we're going to ignore the negative radius. If we have a negative theta, Okay, so we've just done this one. Okay, if I have a negative radius and a positive theta, then I'm going to handle it a little bit different. So I'm going to do exactly what I did here, but at the very end, I'm going to slice through the pole and land in the opposite quadrant. Okay, so if this is your r theta, if they're both negative, that's going to be the worst option. Okay, and it's really not hard. And then if this one is positive and this one is negative, well, then you're still going to move out to the right. You'll just go down and around. Okay, so the negative radius is just going to be what causes a little bit more consternation for you. So again, this option and this option just requires one more little step. So as I grab this one, and again, I'm just going to do this on the bigger paper just so it's easier. So it says identify the point with the given polar coordinates. So I'm going to ignore the negative for just a second. And so I'm going to count out to a positive 3. So I've got 1, 2, 3. And then it says swing around a positive 7 pi over 4. So I'm going to swing out and I'm going to stay on this radius of 3. And I'm going to come around to 7 pi over 4. And now that I'm there, what I'm going to do is pay attention to that negative. And that negative says to slice directly through the pole and land directly opposite. You're essentially adding or subtracting either 180 degrees or pi. That's what you're doing. So I thought if it was a positive 3, 7 pi over 4, I should have landed in quadrant 4. But that negative, which is the last thing I handle, means I just slice directly through the pole and then plop it on back down. Okay, so you're looking for an answer in quadrant 2. So again, here's quadrant 4, here's quadrant 1, here's quadrant 2, and here's quadrant 3. And you'll notice that these ones, they took you all the way around into quadrant 4, and then they sliced you through the pole directly opposite into quadrant 2. So that's your answer. All right, so let's do a few more of these things. We've got 5 and 3 pi over 2. So this is polar coordinates. You got to pay attention because we're fixing to trick you. So I'm going to come out 5. So 1, 2, 3, 4, 5. And where's that going to land me? At 3 pi over 2 means I'm at the negative axis. So this says, and if you'll notice, I'm not at the right angle measure. So that point is way up in the wrong spot. Okay. So you're going to count out 5, which is positive. You're going to swing around 3 pi over 2, which is going to land you right here. And that's not where the point is, but oh, look, there it is. Okay, so he's going to be option B. So it's really not scary. It's pretty dang straightforward. So what if I've got this one? Now I've got a negative angle measure, which is no big deal. Okay, so I've got a positive 3. So from the pole, I'm going to count out 1, 2, 3. And then I'm going to swing down and around instead of up and around. So I'm going to swing all the way around to 315 degrees, which will actually land me in quadrant 1. And so that your first option is right there. So if it's a negative angle measure, you just swing down and around that many degrees. So you know that he's A, okay? And here we have a negative negative. So we know how to handle it. I'm going to ignore this for just a second. And that means I'm going to count out 5. So let's come back over here to this one. So I've got counting out 5 and then a negative 4 pi over 3. So I'm going to count out 5. So 1, 2, 3, 4, 5. And I'm going to go negative 4 pi's over 3, which will land me somewhere in quadrant 2. Okay, but what does this negative tell me to do? It tells me to slice right on back through that pole and land directly opposite at a radius of 5. So you should be looking for an answer in quadrant 4. So when I look at this, oh, look, there's quadrant 4. So here's quadrant 4, quadrant 3, quadrant 1, quadrant 2. So it's got to be A. Okay, so again, we're not being overly scientific about this. We're just saying, hey, I know how to do this. So I'm going to let you do number 6 because I'm trying to keep this to 2 videos and I'm down to 5 minutes. So you can do that one. You can do number 8. You can do number 9. And then we have some interesting stuff. All right, so here's number 10. It says, please plot the point at the right given in polar coordinates, and find other polar coordinates in the form of r comma theta of the point for which, and then they give me 3 different instructions, 3 different sets of instructions. Basically what we want to do is follow these instructions and land right back here at the point 5 comma 11 pi over 6. So if I'm at 5 comma 11 pi over 6, that means I'd count out 5. So 1, 2, 3, 4, 5. And I'm going to swing all the way around to 11 pi's over 6, which is going to be, sorry, right about in there, okay? So that is where I want to land each and every time, okay? So now that I know that, hang on, I'm silencing my cell phone during class. All right, so now that I know that this is where I want to be, okay, so that's step one. Hey, I know how to do that. Now what I would like to do is turn around and say I need a positive I need a positive radius, which means I'm not going to be slicing through anywhere, but I need to move backwards 1 lap in the unit circle. Okay, so basically what that means is I need a positive radius, which will still be 5. But how do I drop down to land there? Because if I'm going to drop down, it's going to be negative. Okay, so I need to land right here by dropping down. Well, if this is a positive 11 pi over 6, that means I drop down 1 pi over 6 to land me in that exact same spot. Does that make sense? So that's what you're looking for. That means I drop down so it's a negative radius. So this just says within 1 backwards lap of a unit circle. So you'll have a negative measure. This one says stay within 1 positive lap of the unit circle. But knowing that, I need to have a negative radius, which means I need to slice backwards. Okay. So if that's the case, that means before I sliced anywhere, I must have stopped directly opposite. So I must have stopped right there in order for me to slice through and get here. So now, how do I get to this point? So to get to that point, I would count out 5. I would swing around 5 pi's over 6 to land me right here. But then how do I slice through to get to right here? Well, there's your negative radius. Okay? So I'm hoping this makes sense. All right, so then the last one is going to be give me a positive radius, but I need to be within a second lap of the unit circle. So in other words, I want to be right here again with a positive radius, so we know that's going to be 5. But instead of starting here and moving around 11 pi's over 6, I need to add a lap because I want to be within a second lap of the unit circle. So 11 pi's over 6 plus 12 pi's over 6, which is 2 pi, is 23 pi's over 6. So that's how you're going to land there with a positive radius. Okay, so I'm going to do that. I think we're going to do that again, and then we'll start some conversions in the next video. All right, so but for this one, for number 11, select the representation, so there's going to be more than one, that do not change your location. So I want to land, regardless of how I get there, I want to land at a positive 6, 110 degrees. So that's your R, and that's your theta. Okay, so I want to land at positive 6. So here's 1, 2, 3, 4, 5, 6. And I want to scooch around 110 degrees, which is going to be somewhere right in there. Okay, that's where I want to be. So I'm just going to look at these and see what happens. Well, what happens if I do a negative 6, positive 290? Okay, so I'm going to count out to 6. And then I'm going to go around 290 degrees, which is going to land me right here. Okay. And then do what the negative says, which says to slice through the pole and land. So that one worked. I landed exactly where I wanted to be. Okay, so try it again. What about negative 6, 250? Well, if I go to positive 6 and then swing around to 250, I'll be right about here. Then do what the negative says and slice on through. Well, I'm nowhere near where I need to be. Okay, so now do this one. So swing out 6. Now go down 70 degrees. So that's going to put me right here. Now do what the negative says and slice through. So he works. I like him. Okay. And then the last one says go positive 6. So here I am. And now go around negative 250. And I land exactly where I want to be. So you got 3 answers that work for that one. So we'll finish up on the next video with how to convert.